Next example, solve 3 divided by dx plus 2y divided by x plus 1 is equal to x cube divided by y square. So this is the Bernoulli's differential equation. So we can write it in the its standard form, dy by dx, so dividing throughout by 3. So dy by dx, 2 divided by 3 in bracket x plus 1 y is equal to 1 by 3 x cube y raised to minus 2. So this is the Bernoulli's differential equation of the form dy by dx plus pxy is equal to qx into y raised to n. So what is the qx? Qx is this 1 by 3x cube. Px is 2 by 3x plus 1. Y raised to n. And n is now minus 2. Value of n is here minus 2. So n is integer either odd or even. So what is the next step? Then multiplying by equation 1 by y raised to 2 y square. Here is y raised to minus 2. So we have to divide y raised to minus 2 throughout. Means we have to multiply y raised to 2 throughout. Multiplying equation 1 by y raised y square, y raised to 2. We get what? Y square divided by dx. So how we can find this multiplication factor? So from this, that is y raised to n is there is the term y raised to n. So in general, if this is the Bernoulli's differential equation, then in order to solve this Bernoulli's differential equation, first step is what? Dividing by y raised to n. Dividing throughout by y raised to n, or multiply by y raised to minus n for this example. So here dividing by y raised to minus 2 throughout means multiply by y raised to 2 y square. We get y square divided by dx plus 3x plus 1 y raised to 1 and y raised to 2 becomes y cube is equal to 1 by 3 x cube y raised to minus 2 and y square. Multiplication is y raised to 0, that is 1. Now substitute y cube is equal to v. This is equal to v. So y cube is equal to v, and so 3y square divided by dx, differentiate with respect to x both sides. So we get 3y square divided by dx, because this is not x cube. If there is x cube, then differentiation with respect to x is just 3x square. But this is y cube, means it is a function of y, and the differentiation is with respect to x. So multiply by dy by dx. 3y square divided by dx is equal to integration derivative of this v with respect to x is dv by dx. And then shift this 3. So y square divided by dx is 1 by 3 dv by dx. Substitute here. Y square divided by dx is 1 by 3 dv by dx. And so equation second becomes 3 divided by 2 divided by 3x plus 1 into y cube is v is equal to 1 by 3x cube. And multiplying by throughout 3. So we have dv by dx plus 2 divided by x plus 1 v is equal to x cube by multiply. And this is equation number 3. Now this is a linear differential equation. So after this calculation, what we have? We have a linear differential equation. So how we can solve the Bernoulli's differential equation? By converting the Bernoulli differential equation into linear differential equation. And now we know that how we can solve the linear differential equation. So first find this is the linear differential equation in v and x. Instead of y and x, there is v and x. So this is the linear differential equation of the form dv by dx plus px v is equal to qx. Obviously px is what? 2 by x plus 1 and qx is x cube. And now find integrating factor. In order to find the general solution of linear differential equation, we have to find first integrating factor, and the formula for integrating factor is I is equal to e raised to integration px dx, that is equal to e raised to integration 2 by x plus 1 dx. Px is this, and then take 2 outside the integration, and 1 by x plus 1 integration is log x plus 1. So 2 and log x plus 2 log x plus 1 is log x plus 1 square. M log a is log a raised to m, and then e and log get cancelled, so we have x plus 1 bracket square. Then general solution of equation number 3 is that this is the equation linear differential equation in v and x. So the general solution of equation 3 is what? Vi instead of yi. The notation is v. So use instead of yi, vi is equal to integration px into I dx plus c. And then substitute I as x plus 1 bracket square in px as x cube, px as x cube, I as x plus 1 bracket square dx. Then x plus 1 bracket square is this, multiplying by x cube we have this, and then integration of this x raised to 5 is x raised to 6 by 6, x raised to 5 by 5, and x cube integration is x raised to 4 by 4 plus constant, and then resubstitute v as y cube, v as y cube here. So we have y cube x plus 1 bracket square this side as it is, and this is the general solution of the given differential equation. So this is the problem on the Bernoulli's differential equation, and we similar to linear differential equation. This is the differential equation, Bernoulli's differential equation in the form of dy by dx plus pxy is equal to qxy raised to n. So instead of y, if we write x and in place of x we write y, then we have the Bernoulli's differential equation. Another form of Bernoulli's differential equation is what? Dx by dy plus pyx is equal to qy x raised to n. So again, what is the method to solve such a type of Bernoulli's differential equation? Multiplying by, that is dividing by x raised to n, or multiplying by x raised to minus n, and solve the differential equation. We have the linear differential equation in the form dv by dy plus pyv is equal to qy. So this is the another form of Bernoulli's differential. Replace x by y and y by x. So we have the another form of the differential equation. So in the for same problem, if we replace y by x and x by y, we have the answer. So write 3 dx by dy plus 2 x by y plus 1 is equal to y cube divided by x square. So take this problem and solve. We have the answer. So this is the type Bernoulli's differential equation. Now we will see the mixed type example, that is the examples on linear differential equation and Bernoulli's differential equation, mixed type example. So first example is solve cosec x dy by dx plus dy by dx is equal to y plus cos x. The given differential equation is written in the form dy by dx dividing by throughout by cosec x, that is multiply by sin x. So dy by dx, and then here we have sin xy, then shift this term to LHS, minus sin xy is equal to sin x into cos x, and this is the linear differential equation of first order, that in the form dy by dx plus pxy is equal to qx. What is px or p is minus sin x, and qx is sin x into cos x. Then find integrating factor e raised to integration px dx, that is e raised to minus sin x, integration of minus sin x, and integration of sin x is minus cos x, so minus minus become plus cos x. So this is integrating factor, and so the general solution of the given differential equation. So we have the direct formula to obtain the general solution of linear differential equation is what? yi is equal to integration q into I dx plus c. So y e raised to cos x as I, integrating factor, integration sin x, q is sin x into cos x, q value of q is sin x into cos x, into integrating factor is e raised to cos x dx plus c. And in order to solve this integration, substitute cos x is equal to t. So minus sin x dx is dt, means sin x dx is minus dt. So this cos x is t, e raised to cos x is e raised to t, and this sin x into dx is minus dt. So we have this, and then use the part rule to obtain the integration. First integration of second e raised to t, integration is e raised to t, minus integration of second e raised to t, derivative of t is 1. So we have, and again integration of e raised to t is e raised to t. So we have this after by part rule. We have this, and then take e raised to t as common, substitute t as cos x. So we have this. So y e raised to cos x is equal to this is the general solution of the given differential equation. So dx plus x dy is equal to e raised to minus y sec square y dy. So this is the example of the form dx by dy. So shift this quantity to RHS, take dy as common, shift to LHS, and then shift the minus x to plus x, left side. So we have this, and this is a linear differential equation of the form dx by dy plus pyx. Now not is pxy, pyx is equal to qy. What is p? P is 1, and qy is what? E raised to minus y sec square y. And then find integrating factor. So what formula for integrating factor is what? E raised to py dy. Instead of e raised to px dx, e raised to py dy, that is e raised to 1 dy, and the integration of 1 with respect to y is y, and then e raised to y is the integrating factor, and therefore the general solution of the given differential equation is, instead of y I write xi is equal to integration q into I dy instead of dx plus c. So substitute the values, and e raised to minus y and e raised to y become 0. Sec square y integration is tan y with respect to y. So this is the general solution. Next example, solve 2 in bracket 1 plus x divided by x minus this is equal to this. So after simplification, that is dividing by 2 1 plus x throughout. So we have dy by dx minus 1 plus 2x divided by 2 1 plus xy is equal to x square root 1 plus x divided by 1 plus x. That is the root 1 plus x divided by 1 plus x is 1 by root 1 plus x. And then this is a linear differential equation of the form dy by dx plus pxy is equal to qx, where px is this minus 1 plus 2x divided by 2 1 plus x, qx is this. And so integrating factor I is equal to e raised to integration px dx is equal to e raised to minus this px is this. And then add 1 and subtract 1. So write this 1 plus 2x as 2 plus 2x minus 1. So we have this as the factorization, and then integration is 1 integration is x minus this is 1/2 log 1 plus x, and then this is the e raised to minus x minus 1/2 log 1 plus x, that is this is the factorization of this 1 plus 2x. So write 1 plus 2x as 2 plus 2x minus 1, because 2 minus 1 become again 1, and then 2 plus 2x take 2 common. So we have 2 plus 2x divided by 2 in bracket 1 plus x divided by 2 1 plus x is 1, and minus 1 by 2 1 plus x, and then integration of 1 is x, and minus 1/2 constant 1 by 1 plus x log 1 plus x. So it is e raised to minus x into e raised to minus become plus 1/2 log 1 plus x. So base same addition of power. So split in the two parts, and e raised to minus x, e raised to log, and this is raised to log 1 plus x. 1/2 log 1 plus x is log 1 plus x raised to half, means log root 1 plus x, and e and log get cancelled. So we have root 1 plus x, e raised to minus x, root 1 plus x. This is the integrating factor. Now the general solution of the given differential equation is what? The formula is yi is equal to integration qi dx plus c. That is y I is this e raised to minus x root 1 plus x is equal to integration q is what? X square divided by 2 root 1 plus x into root 1 plus x e raised to minus x as integrating factor dx plus c. This get cancelled, and 1/2 is constant, and the integration of x square is e raised to minus x dx. And then by part rule, this x square as the first and this e raised to minus x as the second. So part rule is first x square, integration of second e raised to minus x, integration is e raised to minus x divided by minus 1, that is this, minus integration of second e raised to minus x, integration minus e raised to minus x, derivative of first 2x dx plus c. So we have this again, and here is minus plus, this minus and minus become plus, and 2 and 1/2 get cancelled. So x into e raised to minus x, again part rule. So first integration of second e raised to minus x, integration is e raised to minus x into minus 1, and plus e raised to integration of second. So minus integration of second is e raised to minus x divided by minus 1 has become plus 1, and derivative of x is 1, and then e raised to minus x, integration is minus e raised to minus x. So take e raised to minus x as common, we have this, and so y root a1 plus x e raised to minus x is equal to this, and this is the general solution of the given differential equation. So multiplying by here, dividing by e raised to minus x, that is multiplied by e raised to x, we have this step. So write either this as the final answer or this as the final answer. Next problem is x plus y plus 1 divided by dx is equal to 1. So the given differential equation is this, substitute this dx by dy. So this shift this x plus y plus 1 to RHS, and we have dy by dx is 1 divided by x plus y plus 1, and then take the reciprocal of both sides. So we have dx by dy is equal to x plus y plus 1, dx by dy minus x is equal to y plus 1, and this is a linear differential equation of the form dx by dy plus px not px, pyx. Pyx is equal to qy. What is py? Py is minus 1 and qy is y plus 1. Integrating factor is e raised to integration p dy. That is e raised to integration minus 1 dy. That is e raised to minus y. Minus 1 integration is minus y with respect to y. So this is the integrating factor, and therefore the general solution of the given differential equation is x into I. Instead of y I write xi is equal to integration qy I dy plus c. And so x e raised to minus y as the integrating factor, so y plus 1 as q, and e raised to minus y dy as integrating factor. And in order to integrate this, use part rule. So y plus 1, that is first integration of second e raised to minus y, integration is e raised to minus y divided by minus 1, means minus e raised to minus y, minus integration of second e raised to minus y, integration is minus e raised to minus y, derivative of first y plus 1, derivative with respect to y is 1, and then e raised to minus become plus, and again e raised to minus y, integration is e raised to minus y divided by minus 1, so here we have minus sign, and this is the answer. So x dividing throughout by e raised to minus y, so x minus, we have this minus y plus 2 is c into c divided by e raised to minus y, means c into e raised to y, and this is the required solution or general solution of the given differential equation. So next problem is again of the same type. Y plus 2 dy by dx is equal to y cube x minus 1. The given differential equation is y 2 dy plus 2 dy by dx is equal to this. So this is dividing by y cube, dividing by y cube. So we have 3 y raised to minus 3 dy by dx plus y raised to minus 2 is equal to x plus 1. So instead of this, right, this is dividing dy by dx, dividing by 2 only, dy by dx plus 1 half y is equal to x minus 1 y cube, and this is the Bernoulli's differential equation of the form dy by dx plus pxy is equal to qx into y raised to n. So y raised to n value of n is 3. So dividing throughout by y cube. So Bernoulli's differential equation. So this differential equation is of the form, this form, dy by dx plus pxy is equal to qx y raised to n. So this is the Bernoulli's differential equation, and value of n is 3. So dividing throughout by y cube. So this is the Bernoulli differential equation, divided throughout y cube, the next step. So we have 2 y raised to minus 3 dy by dx, y raised to 1 and into y raised to minus 3 is y raised to minus 2 is equal to x plus 1, and then substitute y raised to minus 2 as v, y raised to minus 2 as v, and so its derivative is minus 2, y raised to minus 2 minus 1 is minus 3, dy by dx is equal to dv by dx. So substitute this as dv by minus dv by dx, value of this quantity, y raised to minus 2 as v is equal to x plus 1, and this is dv by dx. Change the sign throughout. So dv by dx is equal to minus v, and write minus in bracket x minus 1 or 1 minus x, and which is linear differential equation in v and x, and this is of the form dv by dx plus pxv is equal to qx, and px is minus 1 and qx is 1 minus x, and so integrating factor is e raised to integration px dx, that is minus 1, integration is minus x, and then the general solution of equation number 3 is vi is equal to integration I into qx dx plus c. So v into I is e raised to minus x, integration qx is 1 minus x, e raised to minus x dx plus c, and so by part rule integrate this. So this 1 minus x is first and e raised to minus x is second. So first integration of second e raised to minus x, integration is e raised to minus x divided by minus 1, means minus e raised to minus x, minus integration of second is e raised to minus x, integration is e raised to minus x into minus 1 or divided by minus 1, and into derivative of first 1 minus x, derivative is minus 1, so minus 1 is become plus, and then next step e raised to minus x, the integration is e raised to minus x divided by minus 1 is become plus 1, and then substitute v as y raised to minus 2, v as minus e raised to minus 2. The simplification is this, and substitute v as y raised to minus 2, and so we have, this is the general solution of the given differential equation. Okay, so solve x cube y cube plus xy dy by dx is equal to 1. Again, the given equation written in the form dx by dy is equal to x cube y cube plus xy. That is, shift this x cube y cube plus xy to RHS, it has become 1 by x cube y cube plus xy, and then take reciprocal of both sides. So dx by dy is x cube y cube plus xy, and then dx by dy is minus yx is equal to x cube y cube. And this is the Bernoulli's differential equation, which independent variables are x and dependent variable is x and independent variable is y. That is, this is in the form dx by dy plus pyx is equal to qy x raised to n. So this is the another form of the Bernoulli differential equation. Write that form: dx by dy is equal to dx by dy plus pyx is equal to qy x raised to n. So now x raised to n means x raised to 3 is the factor. So dividing throughout by x raised to 3. Dividing throughout by x raised to 3. We have this. Then substitute x raised to minus 2 as v. So then we have minus 2 x raised to, differentiate with respect to y now both sides. Differentiate with respect to y. So x raised to minus 2, derivative is minus 2 x raised to minus 2 minus 1, and into dx by dy, because the derivative is with respect to y, is equal to dv by dy. And then substitute this x cube, this shift this minus 2, we have this. The value of this quantity is minus 1/2 dv by dx. So substitute that value, minus y, v, x raised to minus 2 is v, is equal to y cube, and that is dv by dx throughout dividing by minus 2, multiplying by minus 2, we have this. And this is a linear differential equation of the form dv by dy plus 2yv is equal to minus 2y cube. That is, this is in the form dv by dy. So the general form is dy by dx. So y is v and x is y now. And so integrating factor is what? E raised to integration 2y dy. And that is e raised to 2y is y square by 2. 2 to get cancelled. So e raised to y square is the integrating factor. And therefore the general solution of the equation number this 3 is what? Vi is equal to integration q, that is minus 2y cube, into I dy plus c, and that is I as e raised to y square, and then y cube e raised to y square. Substitution is y square is equal to t, so 2y dy is dt. So and this take 2 as 2y, so y square as t, and then y, this 2 and this dy is dt, and this e raised to t. So we have this, or write y dy as 1/2 dt by 2, then 2 to get cancelled, and then t e raised to t, integration is part rule by using part rule. This t is first, e raised to t is second. So first integration of second minus integration of second, derivative of first is 1. And then substitute t as y square, we have this, and then substitute v as x raised to minus 2, we have this, and this is the general solution. So solve the Bernoulli's differential equation y dash minus y x y square. Don't follow this procedure. This is y raised to, this is what? Y dash means dy by dx minus y x y square. So dividing throughout by y square. First step is what? This is of the form dy by dx plus pxy is equal to qx y raised to n. So n is 2. So dividing by y square, throughout dividing by y square, or multiply by y raised to minus 2. So we have y raised to minus 2, y dash means dy by dx, minus y raised to minus 2 into y raised to 1 is y raised to minus 1 is equal to x, and then substitute y raised to minus 1 as v, and then its derivative is minus 1, y raised to minus 1 minus 1 minus 2, dy by dx is equal to dv by dx. Substitute this value of that is y raised to minus 2 dy by dx is minus dv by dx, right here. Minus y raised to minus 1 is v is equal to x, and this is change the sign throughout. So dv by dx plus v is equal to minus x is the linear differential equation in v at x. So integrating factor is e raised to px dx. P is 1. So its derivative is x. Integration is x. So and the general solution of the given differential equation is what? yi in the differential equation, this. So yi. So instead of yi, Write VI, not YI, VI. So here is the step is wrong. VI, right? VI, the general formula is VI means V e raised to X is equal to integration. QX is minus X into I is e raised to X dx. And the integration of this is by using part rule is this step. And then substitute here V, right here V, and write V is as V as y raised to minus 1. So right here y raised to minus 1 e raised to X is equal to this is the general solution of the given differential equation. So these are the problems on linear differential equation for homework. So solve all these problems, and uh, 15 problems in all. There are 15 problems on linear differential equation. So, and these are the uh, 8 problem on Bernoulli's differential equation. So solve all these problems. Answers are given. So if you consider this as linear differential equation, so integrating factor, find integrating factor, and integrating factor is given here. So hints are given and the answers are given. So in each example, the integrating, what is the integrating factor and what is its answer is given here. So solutions are given. The Bernoulli's differential equation also, the given differential equations are Bernoulli's differential equation. This exercise number 31, all these are Bernoulli's differential equation. So identify that Bernoulli's differential equation and then find its solution. So solutions are given, answers are given all. So solve all these problems of linear differential equation and Bernoulli's differential equation. So this is the last topic of our paper number 2, that is calculus 2. So here the syllabus of calculus is over. So solve all the exercise, and if you have any problem, then communicate me with through WhatsApp group or by using your phone. So this is about the paper calculus 2, paper number 2 of our mathematics paper number 2. So we'll stop here.